Look at this question. A function f from R to R is defined by f of x is equal to x square. Determine first one range of f, second set x such that f of x is equal to 4, third y set y such that f of y is equal to minus 1. See here, find range of f. The given function is from R to R, that is set of real numbers, and defined by f of x is equal to x square. And we know that square of any real numbers is positive number or 0, right? Therefore, we know that, see here, what is the domain? Domain is nothing but R itself, right? So, domain of f is equal to set of real numbers R. And range of f, range is nothing but, see, f of x is equal to x square, its square. See, it is a function from R to R. See, suppose minus 1, minus 2, 3, 4 are the elements. So, set of all real numbers are there. Okay, so here minus 1 square is 1, minus 2 square is 4, 3 square is 9, 4 square is 16, 1 square is, okay, etc. See here, we know that here the image, that is elements of range, that is codomain, are always positive and or 0. If it is 0, 0 square is 0 itself, right? So here the square of any real numbers is always positive or 0. Okay. So here, what is the range of f? So range is nothing but there will be no negative values. Okay, in range. See, that is range of f is equal to R plus, yes, set of positive real numbers. Okay, we can write set of positive real numbers, that is R plus. Okay, then next is here second question, set of x such that f of x is equal to 4. See, when f of x is equal to 4, f of x is equal to 4 implies x square is equal to 4, that implies x is equal to plus or minus 2. Okay, so what are the images? That is plus or minus 2. So x values are plus or minus 2. So this set we can write. See, here it is the first one, range of f is equal to positive real numbers. Second, the set is set of minus 2 plus 2. Okay, then next, set of y such that f of y is equal to minus 1. See, as I mentioned before, see here there is no negative values in codomain, okay, that is in range. Therefore, it is not possible. Okay, so there is no negative values in range. Therefore, it is not possible. So, this set is an empty set. Okay. So, here third one is y such that f of y is equal to minus 1. That implies, see, y square is equal to minus 1. And it is the set from R to R, right? So, set from R to R. See here, y square is equal to minus 1 means, see, y will be a imaginary number, right? So, it is a set of real numbers. So, there is no negative values in codomain, that is in range. Therefore, here this set is an empty set. Okay. That is equal to 5 is an empty set. Okay. So, first one is here finding the range of f. See, range of f here according to the definition, that is definition of the function f of x is equal to x square. Okay, function is defined by f of x is equal to x square, and the square of all positive real numbers, not positive, all the real numbers, square of any real numbers is always positive or 0. Okay, 0 square is a 0. Okay, so here range will be a positive real number, set of positive real numbers. Okay, with a 0, and domain is nothing but set R itself. Okay. So next is, see, x such that f of x is equal to 4. F of x is equal to 4 means x is equal to, x square is equal to 4. Therefore, x values will be either minus 2 or plus 2. Okay. So here the set is minus 2 plus 2. Then next is third one, y such that f of y is equal to minus 1. See, f of y is equal to minus 1 means minus 1 will be in our codomain, right? That is in range. That is not possible. Here only there is no negative values in codomain because according to the definition. Okay, so here f of y is equal to minus 1 implies y square is equal to minus 1. That implies y will be a complex number, imaginary number. Okay, so here our set is defined from real numbers to real numbers. Therefore, there is no negative values in our codomain. Okay, therefore, thus this set is nothing but it's an empty set. Okay, so here y is such that f of y is equal to minus 1 is equal to and 5. Okay, an empty set. Look at the next question. Write the following relations as sets of ordered pairs and find which of them are function. Okay. So first one, set of all xy such that y is equal to 3x, x belongs to set 1, 2, 3 and y belongs to set 3, 6, 9, 12. Okay, now we will write the set in ordered pairs. Okay, functions, relations in ordered pairs. After that, we will check whether it is function or not. Okay, so here the relation, here the equation is, okay, condition is y is, that is the relation. Okay, y is equal to 3x. So substitute, see x belongs to 1, 2, 3, right? So substitute x values 1, 2, 3. So when x is equal to 1, x is equal to 1, what is the y value? Y is equal to 3. When x is equal to 2, that implies y is equal to 6. When x is equal to 3, that implies y is equal to 9. Right? X is equal to 1, 2, 3. So here we can write the set is 1, 3, 1, 3, okay, 2, 6 and 3, 9. It is the set. So here no pre-images are repeating. That means, see, every pre-image has only one image. One has a pre-image. See, 3 is the image of 1, 6 is the image of 2 and 3's image is 9. Okay. So here no pre-image is repeating. Therefore, it is a function. This relation is a function. And what about the second one? See, second one. Here xy such that y greater than x plus 1, x is equal to 1, 2 and y is equal to 2, 4, 6. So here also let us substitute x values one by one. So when x is equal to 1, okay, y greater than 1 plus 1, substitute x is equal to 1 so that we will get y greater than 1 plus 1, that is y greater than 2. Y greater than 2 means y is equal to 4, 6, right? So x is equal to 1 implies y is equal to 4 and 6. And when x is equal to 2 implies y is equal to set, see, 2 plus 1, 3, y greater than 3, that is also 4, 6, right? 4, 6. So here we can write the set 1, 4, 1, 4, 1, 6, okay, and 2, 4, 2, 6. These are the elements of this set. And here, see, this pre-image, one has two images, right? See, one has two images, 4 and 6. Here also, 2 has two images, 4 and 6. Therefore, it is not a function. Okay, in a function we know that every element of a domain has only one image in Y, right? In codomain. That is, so here, but here one has two images. One is the pre-image, okay? This pre-image has two images, therefore it is not a function. Next, third one. See, third one, xy such that x plus y is equal to 3, xy belongs to 0, 1, 2, 3. So here also substitute x values one by one, 0, when x is equal to 0, that implies y is equal to 3. When x is equal to 1, that implies y is equal to, when x is equal to 1, y is equal to 3 minus 1, 2, right? When x is equal to 2, that implies when x is equal to 2, y is equal to 1. Y is equal to 1. When x is equal to 3, y is equal to 3 minus 3, that is 0. Okay. Here we have got the set is, elements are 0, 3, okay, 1, 2, 2, 1, 3, 0. See here, every pre-image has only one image, that is 0 has 3, 1 has 2, 2 has 1, 3's image 0. Therefore, here no pre-images are repeating. Okay, no pre-images are repeating. Hence, this relation is a function. Okay, so first one is a function, second one is not a function, and this third relation is a function. If f of x is equal to x square minus 3x plus 4, then find the values of x satisfies the equation f of x is equal to f of 2x plus 1. Given f of x is equal to x square minus 3x plus 4. Okay, so here we have to find f of 2x plus 1. We need to find f of 2x plus 1. See how to find 2x plus 1. So replace, to find f of 2x plus 1, see substitute in place of x 2x plus 1. Okay, so here 2x plus 1 whole square, because f of x is equal to x square minus 3x plus 4, right? So f of 2x plus 1, in place of x you put 2x plus 1. 2x plus 1 whole square minus 3 into, in place of x write 2x plus 1 plus 4. That is here 4x square plus 4x, a plus b whole square form. Okay, so 4x square plus 4x plus 1 minus here 6x, substitute minus to each term. So minus 6x minus 3 plus 4, that is equal to 4x square plus 4x minus 6x minus 2x, and here plus 1, 4, 5, 5 minus 3 plus 2. Okay, so here it is 4x square minus 2x plus 2. F of 2x plus 1 is 4x square minus 2x plus 2. Okay, let us equate this. That is, it is given f of x is equal to f of 2x plus 1. Then what is the values of x? Okay, so here f of x is equal to f of 2x plus 1. That implies, what is f of x? X square minus 3x plus 4, that is equal to 4x square minus 2x plus 2. Simplify this one. So here take the all these right side, so that we will get 4x square minus x square, 3x square, and minus 2x plus 3x plus x. Okay, and plus 2, and take this 4. When we take this 4 to right side, it will be minus. So 2 minus 4 minus 2, that is equal to 0. Okay, that implies, see here we can write it as 3x square. See, x can be written as plus 3x minus 2x, right? Minus 2, that is equal to 0. That implies here 3x is common. So 3x into x plus 1. Here take minus outside, minus 2 into x plus 1. That is equal to 0. Here x plus 1 is common. Take it outside. So x plus 1 into 3x minus 1. Sorry, 3x minus 2, that is equal to 0. So here we have got x plus 1 into 3x minus 2 is equal to 0 are the factors. Okay, so here x plus, that implies x plus 1 is equal to 0 and 3x minus 2 is equal to 0. That implies x is equal to minus 1 and 3x is equal to 2. That implies x is equal to 2 by 3. So the values of x are minus 1 and 2 by 3. Okay, values of x minus 2 and 2 by 3. If f of x is equal to x minus a whole square into x minus b whole square, find f of a plus b. F of x is equal to this one. So find f of a plus b. In place of x, put a plus b. Okay. So f of a plus b is equal to, substitute x a plus b. Okay. So a plus b. Okay. In place of write a plus b. A plus b minus a whole square. Here a plus b minus b whole square, that is equal to, see here a minus a cancelled, so b square. Here b minus b cancelled, so b, a square. Okay, so a square b square. Okay, so f of a plus b is nothing but a square b square. Next question is, if y is equal to f of x is equal to ax minus b divided by bx minus a, show that x is equal to f of y. F of x is equal to ax minus b divided by bx minus a. So what is f of y? F of y is nothing but ay minus b divided by by minus a. So here it is given f of x is equal to ax minus b by bx minus a. So here let us simplify this expression. Y is equal to ax minus b divided by bx minus a. Let us simplify this one so that you will get in the form of x is equal to. Okay, so by cross multiplication, y into bx minus a, that is equal to ax minus b. Okay, so here y bx minus ay is equal to ax minus b. And you take all x terms left side so that you will get it in the form of x is equal to. Okay, so here y bx minus ax minus ay is equal to minus b. And take y terms here, right side, left side, sorry, right side. Y bx, see here in these two terms x is common, right? So take x outside, x into by, okay, minus a, that is equal to minus b plus ay, and take this term right side. So x is equal to minus b plus ay, that divided by by minus a. That is x is equal to ay minus b, okay, ay minus b divided by by minus a. It is nothing but f of y. Okay, because f of x is equal to ax minus b divided by bx minus a. So write in place of x y, then you will get f of y. That is ay minus b divided by by minus a. Hence it is proved. If f of x is equal to 1 by 1 minus x, then show that f of x is equal to x. So here given f of x is equal to 1 by 1 minus x. So what is f of x? See, that is nothing but f of 1 by 1 minus x, right? Because f of x is 1 by 1 minus x. So here we have to substitute, that is in place of x, see what is f of 1 by 1 minus x? F of x is this one. So in this expression, replace x, in place of x you should substitute 1 by 1 minus x, right? Because f of x is equal to 1 by 1 minus x. What is f of 1 by 1 minus x? In place of x, we should substitute 1 by 1 minus x. Okay, that is 1 by 1 minus 1 by 1 minus x. It is f of 1 by 1 minus x. It is f of x. Okay, if it is f of x, it is f of 1 by 1 minus x. Okay, now let us simplify this one. Here 1 divided by LCM. So 1 minus x minus 1 divided by 1 minus x. That is equal to, so this will go to numerator. So 1 minus x divided by, here see 1 minus 1 cancelled. So only minus x is there. That is here, take this minus here. So it will be x minus 1 divided by x. So here we have got f of x is x minus 1 divided by x. Okay. Next here we have to, from the third function we have to find, right? So that is f of x. That is equal to, see, it is nothing but x minus 1 by x. So f of x minus 1 divided by x. This one we have to find. Okay, we need to find f of x minus 1 by x. So what is f of x? This one, right? 1 by 1 minus x. So how to find the f of x minus 1 by x? In place of x, we should substitute x minus 1 by x, right? That is 1 divided by 1 minus x is nothing but, see, in place of x, we should substitute x minus 1 divided by x. Take LCM. 1 divided by, see here, x, take LCM, okay, x minus of x minus 1. So here a minus x, it will be plus 1 divided by x, that is equal to, see here, take this will come to numerator, okay. So x will come to numerator. So x divided by, in denominator x minus x cancelled. So only 1 is remained, that is nothing but x itself. Okay. So here we have got f of x is equal to x. The next question. If f of x is equal to x square when x less than 0, f of x is equal to x when 0 less than or equal to x less than 1, f of x is equal to 1 by x when x greater than or equal to 1, find f of 1 by 2, f of minus 2, f of 1, f of root 3. Okay, let us find one by one. First one, f of 1 by 2. It is given that when x less than 0, the function is x square, f of x is equal to x square. When 0 to 1, when x is between 0 and 1, then the function f of x is equal to x, and when x greater than or equal to 1, the function is 1 by x. Okay. So here, first one, f of 1 by 2. F of 1 by 2, it is obviously greater than 0, right? So, greater than 0, right? See, greater than 0 and less than 1, right? Okay, so it is between 0 and 1. Therefore, the function is x, isn't it? So, f of 1 by 2 is equal to, f of 1 by 2 is equal to, substitute this function, okay? That is, here f of 1 by 2 is the value between 0 and 1, right? It is greater than 1, greater than 0 and less than 1. Therefore, the function is x. So, here substitute the value. F of x is x, okay? So, f of 1 by 2 is 1 by 2 itself. Okay? Then, next, second, here f of minus 2. See, minus 2 is less than 0. Okay, minus 2 is less than 0. When x less than 0, the function is x square. So, put x is equal to minus 2 in this function. Okay, minus 2 is less than 0. Therefore, here the function, consider the function is x square. Okay, here x square. So, substitute x is equal to minus 2. So, minus 2 square, that is 4. So, next one, f of 1. Okay, see here it is given, the second function is when 0 less than or equal to x less than 1. Okay, and when where is x is equal to 1, see, when x is equal to 1, the function is 1 by x, because it is x greater than or equal to 1. Okay, when x greater than or equal to 1, the function is 1 by x. Here not equal. Okay, the function, the x is between 0 to less than 1. Okay, not 1, it is less than 1, something 0.99 something. Okay, so here when x is equal to 1, the function is 1 by x, because it is mentioned x greater than or equal to 1. Okay, so when x is equal to 1, the function is 1 by x. So substitute 1 to x. So here 1 by 1, that is 1 itself. Okay, substitute x is equal to 1. So that here we will get 1 by 1 itself. Okay, next fourth one, f of root 3. See, root 3, what is the value of root 3? Root 3 is nothing but 1.7 something. Okay, so that is greater than 1. 1.73. So that is greater than 1. Therefore, the function is 1 by x. Okay, so f of root 3. So substitute x is equal to root 3 in this function, that is 1 by root 3. Okay, so f of root 3 is equal to 1 by root 3. Look at this question. Find the domain of each of the following real valued functions of real variable. F of x is equal to 1 by x, f of x is equal to x 1 by x minus 7, f of x is equal to 3x minus 2 divided by x plus 1, f of x is equal to 2x plus 1 divided by x square minus 9. So first function, here we have to find the domain of the each of these function. So first one, f of x is equal to 1 by x. See, in this function here we know that here f of x is defined for all real values except x is equal to 0. Because if x is equal to 0, this function will not be defined. Okay. So here this function f of x is defined for all values, all real values except x is equal to 0. Except x is equal to 0. Therefore, domain of this function is domain of f of x is equal to set of real numbers minus 0. Okay, because if x is equal to 0, this function will not be defined. So here f of x is defined for all real values of x except x is equal to 0. Therefore, the domain of f of x is equal to r minus, that is set of real numbers, minus 0. And the second one, see here also, here the function f of x is defined for all real values except x minus 7 is equal to 0. Because here also, if x minus 7 is equal to 0, 1 by 0, that will not be defined, right? So here, f of x is defined for all values of all real values except x minus 7 is equal to 0. That is, x is equal to 7. So, except this value, the domain is, this function is defined, okay? So, therefore, domain of f of x is equal to set of real values, that is real numbers, minus 7. Okay, except 7, this function is defined, that is domain of f of x is equal to set of all real numbers minus 7. Next, third one, f of x is equal to 3x minus 2 divided by x plus 1. So here also, see, denominator should not be 0, right? If denominator is 0, that function will not be defined. Okay. So you have to do first equate to 0. Okay. So here also the function is f of x is defined for all real values except x plus 1 is equal to 0. Okay. Except x plus 1 is equal to 0. The function f of x is defined for all real values except x plus 1 is equal to 0. That is, x is equal to minus 1. That implies x is equal to minus 1. So, when x is equal to minus 1, this function will not be defined. Okay. Therefore, domain of this function is domain of f of x is equal to set of all real values minus 1. Okay. Except minus 1. The set of all real values with except minus 1. That is the domain of this function f of x. Okay. Fourth one, see here also, see in every function, see denominator should not be 0. Okay. So here this function is also, it is defined for all real values except x square minus 9 is equal to 0. Right? X square minus 9 is equal to 0. So here also, if x square minus 9 is equal to 0, then this function will not be defined. Okay. So here this function is defined for all real values except x square minus 9 is equal to 0. So x square minus 9 is equal to 0 implies x square is equal to 9. That implies x is equal to plus or minus 3. Okay. So except these values, plus 3 or minus 3. Okay. Plus 3 and minus 3, except these values, the function is defined. Okay. So therefore, the domain of this function is domain of f of x is equal to set of all real values minus plus 3 and minus 3. Okay. Except these values, set of all real values is the domain of this function. Okay. So domain of f of x is equal to set of all real values except plus 3 and minus 3. So it is the domain of this function. Find the domain of each of the following real valued functions of real variable. First one, f of x is equal to square root of x minus 2, f of x is equal to 1 by root of x square minus 1, f of x is equal to square root of 9 minus x square. So here also we have to find the domain of each of these functions. The first function, given function is f of x is equal to square root of x minus 2. And we know that square of any real numbers is always positive, right? So here that is a number inside of square must be greater than or equal to 0. See, if it is less than 0, it will be an imaginary number, so that it will not be defined because our function is real valued function. Okay, so we can say that f of x is defined only for x minus 2 greater than or equal to 0. Okay, if x minus 2 greater than or equal to 0, this function will be defined. Okay, so here this function is defined only for x minus 2 greater than or equal to 0. That implies x greater than or equal to 2. Okay, only for x greater than or equal to 2 this function is defined. Therefore, domain of this function is domain of f of x is equal to x greater than or equal to 2. So 2 is included. So closed bracket 2 to infinity. It is the domain of this function. Now let us go to second one. F of x is equal to 1 by root of x square minus 1. See, here also root, that is a number inside of a square root must be greater than or equal to 0. But here if it is 0, this function 1 by 0, it is not defined. Okay. So this function is defined only for x square minus 1 greater than 0. Okay, it should not be less than 0, the same as here first one, that is if it is less than 0 means this function will be an imaginary number. Okay, the square root of negative number, it will be an imaginary number. Our function is real valued function, so this function is defined only for x square minus 1 greater than 0. Okay, so here x square minus 1 greater than 0. That implies x square minus 1 can be written as x plus 1 into x minus 1, that is greater than 0. Okay, not equal to 0, because if it is 0, it will not be defined. Okay, so here x plus 1 into x minus 1 greater than 0, that means x less than or equal to x less than 1 and or x less than 1 or x greater than minus 1. That is, the domain of this function is f of x is equal to, here no equal, okay, so less than 1, so minus infinity, starting minus infinity to 1, okay. Next, union, here starting from x less than minus 1 and x greater than 1, okay, plus 1, that is union 1 to infinity. So domain of this function is minus infinity to minus 1, union 1 to infinity. Next, third one, f of x is equal to square root of 9 minus x square. See, here also this function is defined only for 9 minus x square greater than or equal to 0. Okay, if it is 0 also this function is defined. Okay, so here we can say this function is defined only for 9 minus x square greater than or equal to 0. That means 9 greater than or equal to x square. Okay, so that is x square less than or equal to 9. So that we can write x square minus 9 less than or equal to 0. Okay, so x square minus 9 can be written as x plus 3 into x minus 3 less than or equal to 0. That implies x greater than or equal to minus 3 or x less than or equal to 3. Okay, x greater than or equal to minus 3 and x less than or equal to 3. Therefore, domain of this function is domain of f of x is equal to, that is x greater than or equal to minus 3, x less than or equal to 3. Therefore, the function, domain of this function is closed interval minus 3 to 3. That's all. Let us go through next question. Find the domain and range of each of the following real valued functions First one, f of x is equal to x minus 2 divided by 2 minus x. Second, root of x minus 3 modulus x minus 1. The fourth one, f of x is equal to minus modulus x. So first one, f of x is equal to x minus 2 divided by 2 minus x. See, as I mentioned before, here also see denominator should not be 0. So here we can say the function f of x is defined only, it is defined for all real numbers except 2 minus x is equal to 0. So here we can write 2 except 2 minus x is equal to 0 implies 2 is equal to x, right? That implies x is equal to 2. Okay, so here domain of the function is domain of f of x is equal to except 2, this function is defined. So the set of real values, real numbers minus 2. So domain of this function is r minus 2. So here next we have to find range. Okay. See, we know that our function is f of x, range is nothing but the elements of f of x, right? So f of x is equal to x minus 2 divided by 2 minus x. Say we can write it as 2 minus of 2 minus x divided by 2 minus x, right? So here 2 minus x cancelled. So here we have got minus 1. So our range is nothing but f of x is equal to minus 1. Therefore, only one element, that is the range. So range of f of x is equal to minus 1. Okay. Next, second, square root of minus 3. See here also square root of any positive, that is real values must be always positive. Okay. So here this function is defined only for x minus 3 greater than or equal to 0. Okay, otherwise it will not be defined. So this function is defined only for x minus 3 greater than or equal to 0. That implies x greater than or equal to 3. So here domain is nothing but 3 to infinity. Okay, x greater than or equal to, so closed interval 3 to infinity. So what is the range? See here we know that x greater than or equal to 3, right? That means x minus 3 greater than or equal to 0. So what about the square root of x minus 3? See, if x minus 3 greater than or equal to 0, square root of x minus 3, that is it's a square. Okay, its square root will be also positive. Okay, greater than or equal to 0. If x minus 3 greater than or equal to 0, then square root of x minus 3 is also greater than or equal to 0, right? So here square root of x minus 3 is nothing but it is f of x. So here we have got f of x greater than or equal to 0. So the range is equal to f of x greater than or equal to 0. So closed interval 0 to infinity. Okay. Now third one. Let us go through third one. Third one is modulus x minus 1. Okay, f of x is equal to modulus x minus 1. See here, we know that modulus x is defined as modulus x is equal to minus x when x less than 0 and x when x greater than or equal to 0. Similarly, modulus x minus 1 is defined as, that is modulus x minus 1 is equal to minus of x minus 1 when x minus 1 less than 0, minus of, x minus 1 when x minus 1 greater than or equal to 0. In place of x here, x minus 1. Okay. So that is equal to minus x plus 1, that is 1 minus x when x minus 1 greater, x minus 1 less than 0. That implies x less than 1, right? X less than 1. Okay. X less than 1. When x minus 1, x greater than or equal to 1. Okay. So here we have got the function modulus x minus 1 is equal to 1 minus x when x less than 1 and x minus 1 when x greater than or equal to 1. See, this function is defined for all real values. So you see here x less than 1, so and x greater than or equal to 1. So this is included, all the values are included here, right? So all the real values. So domain is nothing but set of all real values. Set of all real numbers. Then what is the range? See here, when x less than 1, we know that here x minus 1 is less than 0, right? When x less than 1, x minus 1 less than 0. That implies, see what is its modulus? See, if it is negative, when we take its modulus, it will be positive, right? So its modulus x minus 1 or x minus 1 greater than 0. Okay, when x less than 1, modulus x minus 1 greater than 0. That is f of x greater than 0. Okay, next here x minus 1, when x greater than 1, x greater than or equal to 1, here x minus 1 greater than or equal to 0. That implies f of x, its modulus. Take its modulus, because our f of x is nothing but modulus x minus 1, right? So modulus of x minus 1 is always greater than 0. Therefore, its f of x, that is f of x is greater than or equal to 0. See, here also we have got f of x greater than 0, f of x greater than or equal to 0. Therefore, the range is starting from 0. Okay, f of x greater than or equal to 0. So, range is nothing but, range is equal to 0 to infinity. Okay. Now, let us go through fourth one. Fourth one, given function is f of x is equal to minus modulus x. Okay, see here, first of all, we will write the function modulus x definition, that is modulus x is equal to minus x when x less than 0 and plus x when x greater than or equal to 0, right? Okay, so what about minus modulus x? So minus modulus x, that is equal to minus of minus. So here it will be minus x, that is plus x when x less than 0, minus x when x greater than or equal to 0. Okay. So here also the function is defined for all real values, right? X less than 0, that is negative values, and x greater than 0, all the positive values. Therefore, this function is defined for all real values. Therefore, domain is equal to R. Domain is R, set of real values. And what is the range? Here we know that when x less than 0, here modulus x, we know that modulus x greater than 0, right? Modulus x greater than 0, that implies minus modulus x less than 0. Here we know that modulus of any value, that is always greater than 0. So modulus x greater than 0, that is minus modulus x is less than 0. Okay. So what is minus modulus x? F of x, right? That implies f of x less than 0. And next, when x greater than or equal to 0, okay, modulus x here, modulus x greater than or equal to 0, that implies minus modulus x less than or equal to 0, that implies f of x less than or equal to 0. Okay. So here also we have got f of x is less than or equal to 0. Therefore, the range is equal to, that is all negative values less than 0. So minus infinity to 0. It is the range of this function.